Alright, so let's finish up the first chapter with our properties of real numbers. Okay? The properties are going to show up all over the place, all the time, okay, in lots of different variations. First, we want to start with the order property. The order property is just what order do we put numbers, okay, and it all comes down to the number line, okay. Everything comes down to the number line when we're looking at the order property, okay. So, any two real numbers. Our number line is only real numbers. Non-real numbers are not on our number line. They go on the complex plane, and that's a whole nother thing, okay? We're looking at inequalities, and we're comparing them. So my first inequality is that I have the real number A is less than the real number B. And that just means that it's left on the number line. It gets a little kind of backwards when we're dealing with negative numbers, okay? So I have a number line, and I have the number A, and I have the number B. If A is to the left of B, then it's less than B. If A is greater than B, then I'm going to have my number line, and A is going to be to the right of B on the number line. Okay, so that's our order property, is where are they in relation to each other on the number line. Less than to the left, greater than to the right. Okay, so I'm going to draw a number line. We're going to fill these numbers in kind of as we go and compare them. Okay, so we're going to insert our less than, greater than, or equal to symbol on each inequality to compare them. Negative 3 compared to negative 4. Is it greater than, less than, or equal to?
Greater than.
It's greater than, because it's to the, which direction?
Right.
To the right. So if I have negative 4, negative 3 is to the right. Okay? Negative 3 is to the right. Let's try that one more time. Okay, better. Okay? 15 over 3 compared to 5. Less than, greater than.
It's going to be equal to.
Because they're the same number. 15 thirds is 5. Alright? Negative 6 compared to 0.
It'd be less than.
Negative 6 is less than 0. Negative 6 is all the way over here. And 0 is over here. And our 5 is way over there. Alright? Easy peasy. Lemon squeeze. I like it. So that's our order property, and then this kind of expands on those inequality symbols. So equations have equal signs, inequalities don't. They have all the inequality symbols. Inequality means not equal to. Alright? Inequality is not equal to. So we have all of our symbols here. We have the equals. We have A is not equal to B. An example would be 3 is not equal to 4. Okay? They're not the same number. Right? Our next inequality is less than. So a number is less than. We just saw those. We had negative 6 is less than 0. Greater than. Negative 3 is greater than negative 4. And then we have our or equal to's. Okay? So the less than or equal to. So we had negative 6, okay, is less than or equal to 0. Negative 6 is also less than or equal to negative 6. We have the or equal to, okay? So we can have them be the same number as long as we have the or equal to, and the same as the greater than. We can have a greater than or equal to can be the or any number larger, okay? Those are inequality symbols. Now, we're going to go into the properties of real numbers, and these show up a ton, okay, in various combinations. Get ready to write, because I'm going to fill these in. I'm going to do my best to write as neatly as possible. Wish me luck. All right? Now, first of all, you'll notice that what operations do I not have on this chart? Division or subtraction. These properties do not apply to division or subtraction. They only apply to addition or multiplication. But, luckily, we can rewrite any subtraction problem as addition and then make it apply. We can rewrite any multiplication problem or division as multiplication and make it apply. So, for example, if I have 5 minus 2 that equals 3, right? Okay, 5 plus negative 2 still equals 3. Okay, so we're going to start with that. We have addition versus subtraction. We're going to look at some of these and kind of see what that difference is going to be. We're going to start with commutative. Commutative means to commute or to move. To move. Okay, commute means to move. Okay, you have a commute to work, a commute to school. You drive there, okay, to move from one place to another. So the commutative property of addition says, hey, let's go ahead and move these numbers around, and it's not going to make a difference. So if I have real numbers, A plus B plus C, I can move those around, and the addition or the sum is going to be the same. Okay, so I could rearrange it to be C plus B plus A, or B plus A plus C, or C plus A plus B. Any order of rearranging, and they're going to be the same value. 1 plus 2 plus 3 is 6. 2 plus 3 plus 1 is 6. 3 plus 1 plus 2 is 6. It doesn't matter the order. The addition is still going to be the same. So when we look at our starting example, 5 minus 2 equals 3. If I leave that as subtraction, and I try to rearrange it as 2 minus 5, does 2 minus 5 equal 3? No, it equals negative 3. Different number, right? I can't do that. But if I have it written as an addition problem, I use that additive inverse. I can rewrite it as negative 2 plus 5. Does that still equal 3? Yes. So I can take a subtraction, rewrite as addition, and now I can apply the commutative property. And that's something that we do a lot in algebra, especially when we're simplifying some complex algebraic expressions. We rewrite as addition, we apply commutative, and then we simplify. Okay? Multiplication property is going to be the same, but with multiplication instead of addition. So if I have A times B times C, it's the same as C times B times A, or any order. I could do B times A times C, or any combination of moving those around. The product will be the same. 5 times 2 is 10. 10 times 2 is 5. Doesn't matter what order you multiply them in, it's going to be the same. Okay? Questions on commutative? Question. Associative. Associative means to associate. Associate is who you hang out with, who your friends, who your peers, spend time with. That's to associate. Okay? So mathematically, the associative property is what numbers are hanging out together. So I have A plus B plus C again. Okay? But associative property, it's very similar to commutative. It does pretty much the same kind of a concept, but instead we're dealing with a grouping. We're dealing with parentheses. Okay? So now B and C are associating with each other. B and C are a group. Okay? And that says, hey, let's add B and C first before we add A. Well, that's what commutative property did up here. We moved the order so that we added B and C first and then A. So it does the same thing. They're very, very closely related. I can just change the grouping, change the order. Well, I don't want to change the order, but I want to change the grouping. Otherwise, it becomes commutative. Okay, A plus B plus C. But now the association is on A and B instead of B and C. Hey, make sure we add before we add B and C. Okay? Multiplication will be the same. A. I don't know why it doesn't want A's. Doesn't like them. A, B, and C. And then let's associate B and C. It's going to be the same as A and B. Those associated with C hanging out on the outside.
So what's the point of doing that?
So when we get, these are very, very simple examples. I want you to keep that in mind. When we get to much more complicated algebraic expressions, being able to change that grouping is going to have a powerful impact. Okay? There'll be times where based on what the association is, we can't simplify it. But if we change the association using this rule, and the rule says, hey, you can do that, that's allowed. You can go ahead and change that association, and then it allows you to simplify it if we put it otherwise. Okay? Identity. That's who you are, right? So who you are. Okay? The identity is who you are. So you are perfect as you are. No need to change. So when we look at an identity and I have a number, okay, and I want to add something to that number without changing that number, what can I add without changing it? 0. So the addition identity is that whenever I add 0 to a number, it doesn't change. Whenever I add 0 to a number, it does not change. And normally this just shows up kind of as a byproduct of simplifying things. We end up combining things, and we'll see it with the inverse, and then, oh, now I have nothing. It's plus 0. I don't have to have that anymore because it's an identity. Plus 0 is an identity. It doesn't change the value of the number. With multiplication, what can I multiply by that does not change the value of the expression? 1. So multiplication identity. Multiplicative, there we go. There's the word. Got it. The multiplicative identity. Okay, we can multiply by 1. And this shows up a lot when we're looking at expressions that we don't have a coefficient or we don't have a number and we need to do something. Well, it's a hidden one. It's an identity. So there's assumed to be a 1 there with a lot of our things. Inverse. It's been a while since I changed color. Let's change color. Inverse is opposites. Okay? Opposites. All right. So our additive inverse, we're looking at the opposite of a number. So if I have a number A, how do I get the opposite of the number? Make it negative. Okay? So my additive identity, okay, my additive inverse is A plus negative A. But when I add a number and its opposite, like 5 and negative 5, what do I end up with? 0. Okay? So our inverse, our additive inverse gives us 0. A number and its opposite adds to 0. Multiplicative inverse. Multiplicative inverse is reciprocal. What's the reciprocal of A going to be? 1 over A. And whenever I multiply a number and its reciprocal, what do I always get? Remember from yesterday? When I multiply a number and its reciprocal, it always equals 1. It always equals 1. Alright? Distributive. Out of all of these, I would probably say at this level in math, distributive shows up the most. Okay? Now, luckily with distributive property, there is no addition example. Okay? There is no addition distributive. There is multiplication though, and it shows up a lot. So I have A being multiplied by the sum of B and C. Okay? A is being multiplied by the sum of B and C. So we have to distribute that A with the B and the C. Okay? A is being multiplied by everything inside that parenthesis. And if I have more things, we will continue to distribute. So this ends up being the same as A times B plus A times C. A times B plus A times C. It doesn't matter if the A is in the front or in the back. So I could have the quantity B plus C with the factor of A on the outside, and I'm still going to distribute to both of those. and get the same solution, AB plus AC. So those are our properties of the real numbers. These show up all the time. And not always by themselves. A lot of times we combine them. We may combine distribute and commutative, or commutative and associative. Or the identities just kind of show up as part of the process, or we use the identity with distributive. So we like to combine them and use them together based on the needs of the expression of the equation. Okay? And there are varying needs all across algebra. Okay? So let's look at a couple real quick. The additive inverse. What's the additive inverse of 9? Negative 9. The additive inverse of 3/4. Negative 3/4. Okay? All we're doing is changing the sign of the number. You want to move up? No? Okay. The opposite or the added inverse of negative 3.5. Positive 3.5. There we go. Okay. So we've got negative 9, negative 3/4, positive 3.5. Multiplicative inverse, the reciprocal. What's the reciprocal of 12? 1/12. No sign change. We're just flipping the fraction. No sign change, just flip the fraction. Reciprocal of negative 8. Negative 1/8. No sign change, just flip the fraction. 3/4. 4/3. Easy peasy, right? Not so bad. Honestly, the big thing is remembering the vocab. Okay? And continuing to remember. Because these words are going to show up from now until May. And then when you come back again the next August, you're going to see them again in whatever class. Because they show up a lot. They're very fundamental to a lot of the algebra and the arithmetic. So what does it mean by additive inverse? What does it mean by reciprocal? And knowing what to do. The actual doing it isn't hard. It's just remembering what it is. So, I would like the additive inverse of 7. Inverse of 7. Good. Negative 7. That's it. Just change the sign. Change nothing else about it. Negative 7. Reciprocal. Reciprocal of 7. One 7. Just flip it. We don't need to make it negative. Okay? We're not asking for the opposite. We want the reciprocal. Flip the fraction. Leave everything else alone. Okay? So using these properties to rewrite an expression. Okay? Again, keep in mind these are very simplified examples. Okay? The application of this goes well beyond just the simple. It goes with the complex, and the point of it is to make complex expressions simpler, easier to digest, easier to manage, easier to evaluate. So, yes, very simple to start, but it's useful for a variety of things. So we want to use the commutative property of addition to write the expression. Okay? So the commutative property of addition says I can do what? I'm not going to change the sign. What is commutative property? To move. And I'm going to move what things? Whatever's being what? Added. I can move whatever's being added. So what's being added in 6x plus 7? 7 and 6x. So I can move those two things. So the commutative property of addition says, hey, put 7 over here and plus 6x over here. Because those are the two things being added together. 6x and 7 are being added. Commutative property of addition says, hey, change the order. Move them around. All right? Now, the associative property of multiplication. Okay? What does the associative property say to do? Okay? So what part of the expression is the association? Okay? 8y is being associated, all right? Because that's in the parentheses. That's being grouped. So if I want to change the association, what's going to be grouped instead? 3 and 8. Okay? So 3 and 8 are going to be associated. Okay? And then the point of that is, oh, now I can multiply those together. What's 3 times 8? 24. Okay? So that's kind of the point of the associative property, is that, okay, 8y is together, but I also have this 3. Well, it's all being multiplied, so let's change that association to be 3 times 8. Boom. Now I can simplify it. Now I've got 24y. All right? Now, I didn't move anything here, did I? All I did was change where the parentheses were, but all the numbers stayed in the exact same order, right? Okay? Note that. That's important. Associative property changes where the parentheses are. Commutative property changes where the numbers are. So what property was used to change 3 times 8y into quantity 3y times 8? Okay. Associate says, yeah, move the parentheses. Our parentheses moved. But why is it both? The y also moved. The y moved. So now I'm, not only am I associating 3 is in my grouping, y is also in my grouping. So y moved and the parentheses moved, which is fine. There's a commutative and associative property of multiplication. I can do both. Okay, but being aware of what's being done. Okay, I applied both. Alright, so we want to use distributive property. And B, we're actually going to combine distributive with something else. So we want to use distributive property to multiply this equation. I can't use commutative and I can't use associative because I'm not doing just addition or just multiplication. I've got multiplication and addition, or I've got subtraction and multiplication. Okay, so I can't apply those, but I can use distributive. And then maybe I can use some of the other ones with it. So, the 4, actually, let me change the way. What does the distributive property do? So what operation is distributing that?
Multiplication.
Yeah. So I'm going to multiply the 4 by the 3x. I'm going to multiply the 4 by the y. So what's 4 times 3x?
12x.
And then 4 times y. 4y. Alright? Now, with B, I'm actually going to use 2 identities, or 2 properties. I'm going to use distributive, but I'm also going to use the identity property. I don't have a number here. So what can I assume that number is? 1. Or negative 1. Okay? So I'll keep the negative, but I can assume that it's negative 1 times the quantity 4y minus 2. Okay, that identity, the 1's not changing it, so I can put it in there, and it doesn't affect the value of my expression, and now allows me to do distribution. So negative 1 times 4y,
Negative 4y plus 2.
and negative 1 times negative 2 turns it into a positive 2. Okay, so use that distributive and use that identity. And if we wanted to rearrange these, we could do commutative now that I have addition. Okay, we could do a little bit of commutative identity if we needed to. Okay, questions on that? Pretty straightforward. In my humblest of. Okay, so then again, we take these properties and we combine them in different ways to take expressions and make them as simplified as we can. And we have to look at, well, what properties can I use? Okay, so my first one here is I've got 4x minus 6x plus 7. So combining like terms. All right, if I have terms that look the same, I can combine them into one term. If I have 4x minus 6x plus 7, which of those terms are the same? 4x. So I combine them. So I have 4x minus 6x, that gives me negative 2x. Is there anything the same with 7? No. So it's just going to come along for the ride. Okay, so we simplify the expression. Okay. Do I have anything the same with b? No. Do I have anything to distribute?
No.
Can I change an association? No. Can I move anything? No. I mean, not to any significant degree. This is already simplified. Don't you love that? When you get a problem where you can't actually do anything with it? Leave it alone. Okay, it's already simplified. Can't do any properties with it to simplify. Let's jump to D. You guys are going to do C in a little bit. So, what property can I use to simplify D?
Distributed.
Okay, let's start with distributed. What am I going to distribute?
4 to x squared.
Let's be a little bit more zealous and let's go ahead and do negative 4. Let's actually,
Negative 4.
let's change that to plus negative 4 so I can distribute that negative 4. All right, otherwise I'm going to have to then deal with the negative that just kind of hangs out there. So nothing's going to happen with the 5x squared yet, or the 2. I have the plus sign. Negative 4 times x squared.
Negative 4x squared.
Negative 4x squared. Negative 4 times negative 3. Positive 12. All right, now what's another property I can use to simplify this? I don't have an operation in parentheses. The parentheses is only there. The parentheses is only there to say, hey, this is a negative.
To combine like terms.
Okay, what property is going to let me move things so I can combine like terms?
Addition.
Commutative. Okay, so our commutative property lets us move things together so that I can combine my like terms. Okay, commutative property lets us move it so all of our like terms are together, and then add those together. 5x plus negative 4x squared.
X squared.
X squared. Okay, or 1x squared. But again, that 1's an identity. We don't need it to write it. It's implied. And then 2 plus 12. 14. Okay, so x squared plus 14. Okay, all right. Are you on the app or the website? All right. How much you want to bet money the internet went out? Don't have to worry about the last activity. So let's go ahead and do 4. So what can I do with C? Okay. So in order to combine like terms, I have to do what? Commutative property. So what am I going to move together? So this doesn't need to move, and then I can add 2xy minus 8. Okay, so 4xy minus xy plus 2xy, 5xy. Okay, 4 minus 1 is 3 plus 2 is 5, and then 3 minus 8. Boom, done. All right.